Okay, now let's talk about thin film interference, part 2. And what we're going to do now is talk about what happens when you enter something that has a coating on it, and then behind it there's something with a greater index of refraction. A couple things to remember. The frequency is not going to change as it enters a new substance. The speed is going to change, so the wavelength is going to change. If you enter something more dense, at that point, there's going to be a phase change. There's going to be a shift of 180 degrees. A crest turns into a trough. Again, here, where I go from a coating with an N of 1.4 to an N of 1.5, there's also going to be a phase change. It's a little bit different than the soap bubble that has air on the other side of it. I'm going to have a phase change twice now. Each one of them is going to change phase. So let's take a look at the next slide. Okay, let's take a look at this. Again, we have air, 1.0, the coating is 1.4, and the glass is 1.5. It's a little bit different than when we were going from air to soap bubble to air. So what's going to happen now as the wave comes in? As that wave comes in, some of it's going to reflect off. Let's take a look at what reflects off for just a second. If I have a crest at this point, I'm entering something more dense, so therefore it's going to flip over and come out as a trough. Now, the part that continues into it, remember, some will be refracted into it. The part that refracts into it is going to come out. That's going to be a crest right there. What's going to happen is it's going to go down and come back out to that point. Now, the key thing to understand is that it's going to flip over again at this point. So what I have to have is a trough and a trough. I have to have a trough right there. So I have to have a trough at this point. So if it flips right here, what's going to happen right there is I'm going to have a 180 degree phase change. So now my extra distance is equal to a full lambda. So now, don't forget the extra distance, like we talked about on the last one, is 2 times the thickness. So now I'm going to say 2 times the thickness is equal to lambda. So if 2 times the thickness is equal to the lambda, then lambda is equal to thickness divided by 2. Where we use these coatings, we use these coatings on glass sometimes. For example, and you will want to reflect the blue skylight and let the other colors through, so where you can see it. Again, we'll do some practice with these in class to help understand them a little bit better. But because this flips over twice, it flips over here on the reflected ray, and this reflected ray also flips over. It has it. Now, one key thing to understand when you're doing this is the new lambda is equal to lambda divided by n. So the lambda itself is going to change also. That's the lambda that's going to need to go in here. And we'll do some more practice with it. Hope it helped.